Hello, my name is Jamie, and today we're going to talk about making parametric crystals using obelisk code. So to give you an idea of what I'm working with using cadquery, if we go to terrain kits and we go down to obelisks, and if I click on this obelisk app, that'll give us an interactive thing to at least get an idea of the code I'm talking about. And so we have this obelisk guy, we can increase the number of faces. And by changing the parameters on this thing, we can get to kind of crystal-like or crystal-adjacent type structures. And the whole point of this code is I want to be able to take this, extend it, and randomly generate crystal-like shapes, and then create a parametric grouping of them. So if I look at crystal terrain, do an image search, not quite like this, but something akin to it, right? So semi-adjacent to crystal-like terrain is what I want to be able to generate. And I think I have a baseline of code that can generate something similar to that. So I made a video series for doing just that, and we'll start going through it. All right, so we're going to attempt to adapt the obelisk code to make crystal-like structures. So here I have CQ editor. I'm copying in a baseline crystal-like structure that I generated off of the interactive editor. Next, I'm going to open a browser and go to the CQ Terrain repo. So this is cadquery helper, but the code I'm looking for isn't located here. So we're going to go to CQ Terrain. Down to miscellaneous. And somewhere in here should be the obelisk code. There we go. And this gives you an idea of the parameters in play and just general documentation for the obelisk. So if I go back to the editor, paste in this example, and run it. Note, to run this code, you're going to need CQ Terrain installed. So pip install CQ Terrain off the GitHub repo. There we go. Now we're back to the original model code. When I actually get to start to writing code, I'm going to double the speed of the video because I tend to write kind of slow. And so to make this a little bit more accessible, I'll speed up the video. First things first, we're going to import in random. And start a stub method. Trying to think about how I want to initialize the height of the parameter. So right now it's a tuple, so it has a min and a max, and then I'm setting up a step. And then we're going to set a randomized seed. So that makes this randomized code. When we initialize random, we're going to set the seed, and that'll allow to create pseudo-random results or repeatable results. I want to make sure I get the typing right, so I'm double checking that in the VS Code. And I'm importing in a range, so I'm unfamiliar with that import, so I want to make sure I had that import right. So NumPy A range allows you to create a range of values based on a step from float values, which is a typical range attribute in Python, just works on integers. The A range works on floats. All right, get my code in sync because I'm out of sync with VS Code and the actual CQ editor. Got my import in finally. And we're going to get a log of our values so we can start seeing it. Do an initialization of the method. Looks like I broke something, didn't get back what I was hoping for. We'll cast it into a string. Oh, I have to initialize it. I never called the stupid thing. Perfect. We'll take off our zero index, and we should get back some values. I'm going to add my step count to the max range of the height, so at least I know I get the top value. So I'll get the min and the max in the list the list of values. And here I am messing around with the step to see if I'm getting the desired results. So based off of that range of values that I'm generating from the step, we can then select a random choice. So we're going to grab our model code, and so if height is a tuple, and I'm going to verify that. Yeah, so if we have a seed, we're going to set our seed. Otherwise, we'll just leave the existing seed alone if we don't set it explicitly on the method declaration. Now I got to verify some code. So I want to verify if the height is a tuple. Otherwise, we're just going to use it directly as is. So we're going to have support for multiple data types for the height. I'm going to check elsewhere in code where I've already done something similar to that. In this case, it's going to be on the terrain code. So I've already done things like this before. Of course, I broke my pathing. That got fixed later. So in this case, I have this guy, probably peaks. And if I look for where that code lives, we're back to cadquery helper. So we're going to find the definition. There we go. So we're going to find our peaks, and we're going to say basically is tuple, I think is how it ends up. Yeah, so type height is tuple. Okay. So if we have a tuple, we can resolve out our range. And otherwise, we'll just use height as is. So if height is a float, without being a tuple, we'll use that directly. So it's a hard-coded value. And otherwise, we'll select a random choice uh, for our height. So now it's variable based on the number of times ran. So based on the seed fed in, we'll get a variable height. And we can start modifying our model. And basically, what I'm writing in this crystal random is a wrapper function around the obelisk code in order to set in min-max values with a seed in order to create pseudo random. That's the general pattern you're going to see here. So take concrete code, add a wrapper around it for accepting ranges, and then use that to generate results. Yeah, so now we got something completely different. So if I change the seed, the height should be variable now. And so if I set it to a hard-coded 50, it'll use that. If I set it to a tuple, a min-max, things should hopefully start happening. And here I think I'm just testing to see if we're setting the seed appropriately based on whether that value is assigned or not. And apparently I was having a kerfluffle with the seed. And that becomes a rabbit hole that I just don't want to deal with at the moment. So more or less, whenever you run Python code, the seed is always being set. The only difference is whether it's a randomized timestamp or a value that you explicitly set. And so retrieving that becomes a bit of a pain. And so that's going to become a rabbit hole I'm just going to quickly abandon. Do some code formatting, clean it up. Change from step to height step because I'm going to have multiple of these values. In the end, I'm going to end up going with something, refactoring to something different, but that'll work for now. So now we're going to set up the number of faces to be a min-max types value set. And we're just doing some code copying. So now if we change our seed, things should start happening. Yeah, okay. So there's the 4 faces, and there's more. And then that's a hard-coded value. So here we're making it a range. And just verifying that it is changing based on the seed. Now I'm starting on group code, so I can display a number of seeds and then the related output. This is basically this goes back to that idea of repeatability and the ability to compare multiple results on a given seed. So now I'm going back to menu for all, looking up the code for the R array. We'll replace that box 111 with a callback method. For now, this is just a test that we can get the grid set up. There's a rough grid. We set up our X spacing and our Y spacing, space it out. And then each of those nodes is going to get replaced with an obelisk. Translate our grid in reference to our baseline obelisk or crystal. So we'll leave the original crystal alone, and then we'll have the grid below it with a bunch of variant. Start setting up the callback method. So the idea is that on each call, we'll generate a new um, randomized crystal and pass in a different seed. Create crystal, pass in the given location. Oh, this is doing the closure. I'm making a closure right now. So I'm making a wrapper method. We're going to return back a callback method. And then on each instance, we're going to up that counter. So that count is going to be in closure scope. There's probably other ways to do this, but this is the one that is kind of back to JavaScript days for me. So we're going to put in the non-local count variable. We're going to create our seed, and then we'll base that off of whatever the value of count is on the time of this iteration. Grab our crystal code, the instantiation code. Clean up our method signature. And instead of seed of purple, we'll set it to whatever the count is. And we're also going to add the value of the seed at the time of iteration for this particular node instance. That's changing the location at for where it's located at. Set up our each point. Yeah, okay. So the way this is work is we're going to instantiate create crystal adder or generator or whatever it finally decide it is. We're going to create that guy, and then that's going to return back our callback method, the internal callback. So we're going to return back add crystal. So like I have crystal adder that returns add crystal, and there we go. We got a bunch of crystals without a modified seed. So our seed didn't quite work on this first pass. Trying to figure out what I did wrong there. There we go. We gotta increment it, and then I've got to place the text in a location where I can see it. Make sure I call it in all the right places. Okay, we've got some variable crystals, and then right now I don't see the text, so I gotta change the spacing a bit. We'll move the text uh, along the Y dimension. And then hopefully it starts showing up. There we go. And so I need to fix that a bit, change some placement, probably change the size of the text, the height. That looks a little bit better. So right now it has randomized heights and randomized the number of faces. And effectively when I'm saying random, just interchange that with pseudo random. It's not truly random, it's generated random, right? Yep, so I'm happy with that so far. Yeah. So we're gonna add more min-max values. And now I'm thinking about that step, right? So the height tuple, define out the type annotations. So it can be a tuple of type float float. Here I'm coming to the aha moment of like, well, what if I just include step in our list of tuple values? So if I have min, max, and step, then I don't have to have two parameters in the method signature. Now I'm having a variable type of int. In at least in CQ editor, that's not enforced. When you actually run the code, compile it like pip install, you can use a specific builder in order to enforce those type annotations. But at the moment, this is just basically for setting the type annotations as a helper for VS Code and the like. They'll pick up on the type annotations, and when you start writing new invocations, it'll tell you what types it can be, and it'll show red squiggly text if you got the wrong types, all the good stuff there. So on our invocation, we're adding our number of steps. And I think here, oh, okay, I got another place to set it because it didn't change anything. And so the idea is if I change the step on the number of faces, it should change the output. Okay, so here we're messing around with the counts. I'm going to output everything to a container scene, and then I'll display that out. Yeah, there we go. So I'm going to tie the translation of the array based on the size, and then that'll move the positioning so it's dynamic. And note the while I'm here, note the placement of like test one, test two, and test three. It's counterintuitive how the nodes are written out. It's basically starts in like that bottom left corner and fills out kind of in a reverse order. Now we're going to start making mid height a tuple value. So min, max, and step. Get rid of some code I don't need. Comment out some code I don't need. Here I'm just cleaning up the example. So now's a good time to plug this. When this video gets posted, I'll post up the code, this code example to go with it. It'll be tied to the Patreon post. For this video, the Patreon post will be accessible to anyone, so you can get to it. But that's where the association will be made. I'll just upload the script right when I set up the video link. So effectively, all those different values I want to make into tuples. So we'll start with the top height. And now I'm having kind of my next aha moment. Because I'm going to be doing this repeatedly for multiple values, I'm going to make a helper function. And as with anything, naming is always the hardest part. So we're going to pass in our tuple set. We're going to say if our tuple set is of type tuple, and we're just going to do dry. Don't repeat yourself. So we're just going to generify this code out. So for each instance of this, instead of repeating the entire if block, we're going to say if resolve variable height, resolve variable val for height, and then our faces will be the same deal. And then hopefully implementing these new tuple variables should be easier because we've got a helper function to go with it, right? So here's what it looks like with a hard-coded, and here's what it looks like with variable. What I'm opting to do is that when I return back my generated crystal, I'm also going to return back the generated height of the crystal. So then when I'm placing it in a group, I can dynamically position these in reference to each other. So I can set the height of the crystals according to a baseline, right? So we're going to do a translate on it. And so they're all going to be, the bases of the crystals will all be at the same level. Hopefully. Yeah, so I'm going to bottom out the base of the crystals on the z-axis. And we'll apply the label somewhere in between. Okay, so now we're going to add top width, make that a variable. Take the annotation, copy that over, the type annotation. Change the seed, hopefully the grouping changes, modifies out. Fighting with something. Yeah, okay. So to recreate, you have to do something with the arguments exactly. Oh, okay. So yeah, okay. So to recreate a given seed, you have to have the exact arguments in them. All right, I see what I'm doing. Trying to see if my example crystal at the top, if I can recreate it from the group. I gotcha. All right, so we'll work on the mid height. reorder some of the parameters. Grab our annotation type, add a min max and a step. That's going to generate the same results. We haven't applied our change yet. Gather our mid height off the resolved range. Apply it there, and then hopefully code should change. Or the output should change. Helps if I spell correctly. And we should start getting variable generated output. So that was mid height. Try it with a hard coded setting. So they should all be the same. Change it to a tuple. And we should start seeing some types of variation. Next in the list, mid width. And then verify if I can get results out of this thing. Well, okay, so based on changing the values, see what general kind of outputs I can get out of it. Okay, some hard-coded values, which should be able to, yeah, that's an easy peasy Boolean. And that'll wildly change the output. So one, verify what it looks like when the intersect is set to false. Set intersect to something other than false, hopefully. There we go. Okay. So that's what the generate output looks like when we change the intersect Boolean value. Cool. And I think we're getting close to the end. Might have one other one to do, one or two other ones to do, but we're getting close. It's just the same repeated pattern. We're just adding these tuple values to different parameters, and then that allows us to set either hard-coded values or dynamic ranges. Yeah, so you see here I'm starting to, we're just gonna shortcut these, and they're all gonna be capable of being tuples. And testing some generated values. So hopefully, I'm getting close to the end here. Assuming I don't break it, but we'll see. And it helps if I apply them. Yeah, okay. Pyramid height. See if that changes at all. And right now I'm just trying to feel out what I can do with this thing. The hard coded value. See if that still takes. And they should all be the same for along one particular dimension. And then we'll change the seed. See what that does. Change the face step. Yeah, okay. And change the intersect value. And there we go. Something happened. And right now I'm just admiring my work. Change it back. And there we go. Cool. And right now I'm just in the piddling stage. Making sure things kind of work how I expect them to. Because part of this whole process with the procedural generation is there's a lot of discovery in it, right? What min max ranges look good. You're never quite sure. There tends to be a fair amount of fiddling to get a feel for it. Go back to the original seed. Yeah, and that's a nice amount of variety, right? Try out a different seed and see what the different results are. Okay, so good enough for now. All of this code, so that'll do it. All of this code has been committed into CQ Terrain under the crystals module, so there's documentation for it, the whole deal. Thank you for watching. I appreciate it. And thank you to my Patreon supporters. Okay, thank you guys. Appreciate it. Have a good one.